last one, number 8 of the Kinematics Review worksheet. It says a motorcycle cop is parked at the side of a highway reading a magazine and is passed by a woman in a red Ferrari going 90 kilometers per hour. After a few attempts to get a cycle started, the officer roars off 2 seconds later. At what average rate must he accelerate if 185 kilometers per hour is his top speed and needs to catch her just at the state line 2 kilometers away? Okay, the first thing I would suggest doing is putting everything in meters and seconds and so on, standard units. So 2 kilometers away would be 2,000 meters. That 90 kilometers per hour turns out to be 25 meters per second. And the 185 kilometers per hour turns out to be 51.38 repeating meters per second. So, the first thing I would suggest doing is she has constant velocity motion. So let's figure out how much time it takes for her to travel. So, D equals V bar T of the Ferrari. F stands for Ferrari in this case, times delta T. This would be 2,000 meters. Her velocity is 25 meters per second times delta T. And we can solve this and we get delta T to be equal to 80 seconds. So he's got 80 seconds to get there. Not quite. Take him 2 seconds to get his motorcycle started. So actually, minus 2, he has 78 seconds to catch her before she gets across the state line and get a ticket. So he's going to be accelerating, and so he's got constant acceleration motion. So delta x will be equal to VIT plus 1/2 AT squared. This VIT term drops out at 0. Initial velocity is 0. So again, he's going to have to travel 2,000 meters. 1/2 of the acceleration is what we're trying to find, times the time of 78 seconds squared. And so we can go about solving this, and we get an acceleration is equal to 0.657 meters per second each second. Now, that's what he has to have. Can he do it though? We don't really know. All we know is that's the maximum speed. So let's figure out what would happen. So here, let's figure out that final velocity that you have. VF would be equal to VI plus AT. VI again is 0. So final velocity is going to be equal to, let's say, that acceleration of 0.657 meters per second squared times the time of 78 seconds. And you get a VF of equal to 51.28 meters per second, which is less. Barely. He's barely able to catch her. He's redlining that puppy. So he might give her a ticket, but maybe he might end up blowing it up. I don't know. But that's the acceleration he has to have.